Hello, this is Mr. Stansbury. I'm going to take you through the notes on the unit circle. At the end of this, you should be able to say I can find multiple angles with the same trig ratios. Okay, so first thing to take a look at here is the unit circle. Unit circle is simply a circle with a center at 0, 0 here. So the center here is 0, 0. That's a 0. And has a radius of 1 unit. So from here to here is 1, here to here is 1. Anywhere along this circle here, this distance is going to be 1. Okay? Radius is 1. Now, the next thing on angle measurement from here, unlike what we did with bearing angles, you always start out here at due east. Okay, so this line right here, let's highlight that. This line right here, this is where we start. Okay, so from due east, and if we go clockwise, counterclockwise, it's positive, and clockwise is negative. Okay, so this would be angle theta right here, starting from due east, heading over. Okay. So what let's do now is let's just take a look at some examples here. I think this is going to help make this make a little bit more sense. So what we're going to do here is we're going to find the coordinates of the point, this red point here, to 3 decimal places. Okay, so we're going to have a coordinate here with an x and a y, and what we're going to do is we got to find that distance x and that distance y for this coordinate here. Now, it does not say on here, it should say that this is a unit circle for each of these. Okay, so if these are unit circles, that means that all of these lengths here are 1. Okay, and really the most important ones for us, the ones we want to keep in mind are that these radius, this radius here, our end point, our end line, terminal line here is 1. So we really don't need to worry about these two as much. So I'm going to actually get rid of those. And what we want to focus in on is that this here is 1. So if we're looking for this point here, we got to find the x and the y. So basically the x here is, if we take this line here and we draw, let's draw it in a different color here. We draw this line here, x. This distance right here is going to be the x, right? And then to go up that far, this distance here is going to be the y. And we just made ourselves a right triangle. So if we're looking for the x and the y coordinates, we want to find this x distance and this y distance. Okay? So here's the good news. We know that this angle here is 41. This radius here is 1. So we actually have an angle and a side, so we can find these other two sides. So if we want to find this side right here, this side here we're going to call is the adjacent. So we'll try to find the x first. So this is the adjacent, and this is the hypotenuse, right? So what we're going to do is say, oh, adjacent and hypotenuse. If we remember our dear friend SOHCAHTOA, that's an O. Right? If we remember SOHCAHTOA, we have adjacent, we need the adjacent, and we have the hypotenuse, so that's cosine. So what we'd want to do here is do cosine of 41 equals adjacent, which in this case is x, divided by the hypotenuse, which is 1. Okay? And we know if we divide by 1, that's just really the same thing as x equals cosine of 41. So we know the x coordinate, all we got to do is type in cosine 41 to come up with our x value. Okay? Now if we want to come up with the y value, this now is over here, we want the y now, which is the opposite. And we now don't care about the adjacent, so we get rid of that. And so we're looking at opposite and hypotenuse, which is sine. So what we want to do there is take sine of 41, and that's opposite, which is y, over hypotenuse, which is 1, which then, just like what we did over here, y is going to equal sine of 41. So this y coordinate is going to be sine 41. Okay, so if we want to come up with the actual coordinates here of this red point, we're just going to do cosine 41 on the calculator and sine 41 on the calculator. So on our calculator, making sure we're in degrees, we're going to do cosine 41, and that gives us 0.7547, and it says to 3 decimal places, so 0.755. So 0.755. That's this distance here. So from here over to here is 0.755. And then if we're looking for the y coordinate here, we're going to do sine of 41. So now we clear that out and do sine 41, push equals, and we get 0.656, 0.656. So that means from here down to here is 0.656. That distance there is 0.656. So to get to this point right here that's got an angle on the unit circle, it's got an angle of 41, we go over 0.755 and up 0.656. Okay? Okay. Taking a look at this one here is we've got 139. So to come up with this angle, sorry, this coordinate up here, we do the exact same thing that we just did, which is we're going to define the x and the y. So the x is going to simply be, even though it's more than 90 degrees, that's totally fine. We're still going to do cosine 41, and y is going to be, oh, it's not 41, sorry, cosine of 139. Just looking at the other one over there. And then this is going to be sine of 139. It's just this angle right here for both of those. I'm going to rewrite that so we can see it. That's a little better. So to find the coordinates of this point here, cosine 139 and sine of 139, and away we go. So we do cosine 139, and we get negative 0.756. Let's see. Let's do this in red like we did the other one. Negative 0.756. And then we're going to do sine of 139. I get the buttons pushed. There we go. 0.656. So that's going to be the coordinates of this point right here. So starting from 0, 0 right here. So remember, this is 0, 0. This is the origin. Same thing here. This is 0, 0. So starting from this one here, we're going to go to the left, since it's negative 0.756, and then up 0.656. 756, right? Yeah. Okay. 75. Let me double check this for a second. Hold on. 0.755, negative 0.755. So that's the coordinates for this one here. Now, if you'll notice, look, these two actually happen to have the same y value, and they actually have exactly opposite x values. So basically what's happening here is this point here is the exact same height just over here on this side here. So we kind of rotate through on this circle here, come over to here, and we end up at this point here, and we end up with the exact opposite sign. 0.755 now turns into negative 0.755 because we're going to the left, but it's still going up 0.656. So it's still 0.656. And the big thing I want you to understand here is if you look at these two numbers here, 139 plus 41 happen to give us 180 degrees. So the supplement, meaning the two angles add up to 180, the supplement of this angle here, which is 139, will end up having the same values here, except for since this one's going to the left, it's going to be negative 0.755. Okay? Okay. Reason why I'm mentioning that is that's going to help you with problems 3 and 4 on your assignment that you're up to. Okay? Okay, that's the big important stuff that we need you to know for the unit circle. So if you have any further questions at all, please feel free to ask in class. Okay? Thanks.